Alright, welcome back to part 2 of the Pre-Calc 9.2 video. The topic for this portion of the video is dealing with finding the sum of a finite arithmetic sequence. So I've got a formula here for you that we're going to use. I'll explain the formula in just a minute, but I think it's best to kind of look at an example first of when we can use this formula, then talk about what the formula, or how to use the formula. So if we look at this problem, it says find the sum of the integers from 1 to 100. So basically I want you to do 1 plus 2 plus 3 plus 4 plus keep going all the way to 100. Well, we could take the time to get out our calculators and start typing that in. That's going to take quite a bit of time though. So this formula here is the shortcut to it. Now the things that you need to know to be able to use the formula is n, the number of terms, a sub 1, the first term, and a sub n, the last term. So looking at this problem here, n, a sub 1, and a sub n is from 1 to 100, that's 100 numbers. The first number being 1, the last number being 100. So plugging it into the formula, if I write the formula down over here, it would be 100 over 2 times 1 plus 100, and so that gives us 50 times 101, and that gives me 5,050 as my answer. Again, I could verify this by taking the time to add 1 plus 2 plus 3 plus 4 plus 5 and so on all the way up to 100, but that's going to take me quite a bit of time to do that. So this is the shortcut to not having to do all of that. The next one says to find the sum of the first 50 even positive integers. So the first 50 even positive integers says do 2 plus Alright, let's try this again. I'm having some issues with the board. Alright, hopefully I've taken care of those issues. Let's start this one over again. Find the sum of the first 50 even positive integers. So like I was saying, that would be 2 plus 4 plus 6 plus 8 plus, and I keep going until I get to 50 integers altogether. So here's the problem that I see with that is how do I know where my stopping point is? I know if I'm going to use the formula that my a sub 1 is going to be 2, there's going to be 50 integers, but what is my a sub n going to be? So what I want to do is I want to plug that into my arithmetic sequence formula. I remember that my arithmetic sequence formula is this. And in this sequence here, if it keeps going and going till it's 50 numbers total, I know that we start off with a 2, so that'd be in my a sub 1. I know there's 50 numbers altogether, and I know that the common difference between each of these numbers is 2. So from here to here is 2, from here to here is 2. So I can find then the 50th term of the sequence by putting in an n of 50, because there's 50 numbers. So in this case it would be 2 plus 49 times 2. 49 times 2 is 98. Add that, I would get 100. So the 50th term of the sequence would be 100. You could figure that out also if you just started counting by 2's. You'd know that you'd have to get all the way up to 100 if you do 2 times 50. But if you weren't so sure about what the exact ending spot is, you can use the formula here to find the, in this case, 50th term of the sequence when you know the common difference is 2, and it starts out at 2. So we know now that the 50th term of the sequence is 100, so that would be my ending values. So plugging it into the formula, if I'll take the time to write the formula down here again, it would be 50 terms divided by 2. The first one is 2, the last one is 100. So 25 times 102 gives me 2,550 as the sum of that. So again, what made this problem a little bit more difficult than the previous one is I didn't know what my 50th term was. So I could take the time to list these out, 50 terms if I want. Again, that's going to be time consuming. So use the formula to find the 50th term of a sequence because you do know the starting value and you did know the common difference. And then we knew we were trying to find the 50th term. So that's how we were able to get that as 100. Then the second formula we used was the summation formula. And again, the only reason I'm able to use this formula here on this problem and the previous problem is because I had a finite sequence. It started at 2, it ended at 100. And so the shortcut, instead of me having to type in the calculator 2 plus 4 plus 6 plus 8 all the way to 100, is to use this formula.